Okay, what do we have here? We have got the inverse of exponential functions, and here is a nice example to just illustrate this kind of question. We are basically sitting with three different types of graphs here. We've got a graph f, that's the blue one in front of you, and that's just a very normal exponential function that we have over there, all right? We've got graph h, which is the orange one, and if you look at graph f and graph h, can you see that they're a reflection of each other about that y-axis, okay? So obviously h is the reflection of graph f about your y-axis. And then we've got the green graph over there, and do you notice that the green graph and the blue graph are actually an inverse of each other? If I were to take a line of y equals x and draw it through, in fact we can do so. If we put a line of y equals x through these two over here, we can see that they are inverse functions of each other. Okay, so there we go. All right, so obviously the equations that are coming, I'm quite sure, are going to be about finding the equations of each of them and determining what happens to each of the equations according to each of those reflections. All right, so I think you notice starting off over here, no equations have been given to us. No one said anything about any equations. So I think that's definitely going to be the first thing we have to do, and it is, okay. F of x, if f of x is equal to a, find the value of a if the graph passes through the point of 2 and 9 over 4. Okay, so your graph f, remember, is the blue one, all right? So it's an exponential function. All right, and in fact, I need to make a small correction over here because your equation is going to be a to the x. So let's just fix that. It's an a to the x is the original function. Okay, let's just make sure that that's fine. All right, so what do I do when you have got an equation and you've got a point that passes through that equation? You substitute that point into the x's and the y's. Remember, f of x is another way of referring to y, so therefore instead of y, we're going to replace y with the 9 over 4, and I've got a to that, and instead of the x, we're going to replace that with a 2, okay? Right, so that's what we've got there. It's an exponential equation that we need to solve here, and remember, if you've got something like 9 over 4, prime factorize it. So 9 is 3 squared and 4 is 2 squared, so therefore the entire, because they're both squared, we can write it as just 3 over 2 all squared, and that's equal to a to the power of 2. Okay, how do we get a entirely on its own? I would raise it to the power of 1 over 2, okay, because that would cross cancel, these would cancel out. But similarly, what happens to the one side happens to the other side, where those would cancel, and we're getting 3 over 2 as our value for a. All right, so what is our f of x function over here? F of x is going to be equal to, instead of just a, we've got 3 over 2 to the power of x. Okay, so there we go. That's the f of x function equation. Now they're saying determine the equation of g of x if g is the reflection of f, is your f to the negative 1 of x. So let's just quickly have a look at where g is. Okay, the green graph is your g graph, and it's the reflection about that bright red line over there, which is your y equals x line. Okay, what do we know to do with an inverse function? Swap the x and the y around, exactly. So we're going to start by saying, so we're working with this equation here. We're going to swap the x's and the y's around, which means I'm now sitting with 3 over 2 to the power of y, okay? And again, we have this exponential equation. Y is sitting up here as an exponent, okay? And you need to make y the subject of this equation. The only way that that is going to happen is if you write it from exponential form, as it is at the moment, into logarithmic form. So you need to change it into a log. And if you recall, remember, y then becomes the subject of the equation. So we'll say y equals log. The base of the y was 3 over 2. So therefore 3 over 2 is the base of your log, and the power is x. Okay, and there we go. That is the inverse equation of your f of x function. So let's just take a second to look at this here. The blue line is your exponential function. The green line is now your logarithmic function. And remember, an exponential function and a logarithmic are always the inverse of each other, okay? And little points such as an exponential function will always pass just without any shifting, will pass through the y-axis at +1. Your logarithmic function is going to then pass through the x-axis at +1 because it's the inverse of each other. Okay, so there we go. So just remember, your log and your exponential graph are always the inverse of each other. Now they're asking for the equation of h, if it's symmetrical about the f on the y-axis. Okay, so we spotted that right in the beginning, hey? We've established that our f of x graph is 3/2 to the power of x. That's the equation of my f of x function. The rule is, if we're reflecting something about the y-axis, then it's the value of x in the equation that changes sign. So your h of x equation is going to be, you've got 3/2, but instead of just x, we're now changing it to negative x, okay, because we're changing it because of it reflecting about your y-axis. Again, I don't like leaving it so much as a negative x, so what we're going to do to finish this off is I'm going to say h of x is then equal to, instead of a negative exponent, do you remember we can swap the fraction around, so I can write this as 2/3, and that will then make that a positive x. And there we go. That's the equation of h of x. Write down the domains and ranges of your f, your g, and your h graph. So let's talk about the blue one to start off with. The domain, remember your domain is how wide on your x-axis, what values of x your graph is spreading out on your x-axis. Now, if I look at this graph here, can you see that it's going to be going infinitely to the left and it's going to be going infinitely to the right? The only reason it's stopped there is because that's as far as the graph is allowing me to go on the picture, but it'll continue going endlessly to the left and to the right. So the domain of this function over here, the domain of graph f, is going to be equal to an element of any real number. It's going from the left and to the right infinitely on both sides. Your range, however, is a little bit different. If I look at how low this graph goes on the y-axis, can you see that it gets very, very, very close to 0 on the y-axis, but obviously it will never get there. You cannot ever get to a 0 on an exponential. So it's getting infinitely close to 0, but never actually touching, and then it continues going up all the way up to infinity over here. So that's going to keep getting higher and higher. So as far as the range of your graph f goes, that's going to be, now can you see I'm going to use a round bracket, because a round bracket means it's never actually including that value of 0, and then it's going to go off into infinity up on the other side. All right, let's look at the domain and range of the other graph. Let's do the orange graph. Again, your x's and your y's are going to be spreading infinitely to the left and to the right. So the domain of graph h is going to again be an element of any real number. The range of your graph h, well, again, it's getting very, very close to 0 as it goes down on that side over there, but it becomes telescopically close to 0, but it will never actually get there. All right, however, it will continue infinitely going higher and higher from that side there. So once again, the only difference here is that no, it would keep in the same order. So it would be from 0 to infinity on your y-axis. Okay. Then your G graph. This was your G graph, the domain of my G graph. Here we have a problem because it's going to tend closer and closer and closer to 0 on the x-axis, but here it's never ever going to touch 0 on your x-axis. So your domain is going to be going from 0, but then obviously it's going to head off into infinity on that side, so from 0 to infinity. But the range of graph G is that will be infinitely down to the negatives and infinitely up into the positives. So that will be an element of any real number. Okay. All right. So there we go. So very, very typical questions of what you can expect. Know your domains and ranges. Know your laws of reflecting and in finding inverses. And you should find that a very nice, easy section to get yourself through. We will see you in the next video. Well done.